Dave Staldlin here. Let's solve one of these folding paper problems. Okay, so we need to write an equation to model the thickness of a sheet of paper after folding it in half t number of times. So, and then determine how many times you have to fold the paper in half to, let's do this one, to reach 1/4 mile tall. Well, you'll recall y equals ab to the x, where this is the starting value, this is the growth factor, that's going to be the number of time periods. But in our case, we want to have the starting thickness, okay? And so our starting thickness is going to be 0.001 centimeters. The problem is that we need to figure out our thickness in miles. So let's use our conversion factors. 2.54 centimeters is 1 inch, and then 12 inches is 1 foot, and then 5,280 feet is 1 mile. And let's see, centimeters cancels, inches cancels, feet cancels, and we're left with the unit miles. And so now let's do this calculation. So we're going to start with 0.001. Anything on the top we multiply by, anything on the bottom we divide by. And times 1 times 1 times 1, those do nothing, so we'll just do the divided by 2.54, divided by 12, divided by 5,280, and it looks like 0.001 centimeters is the same as 6.21 times 10 to the -9 miles. So when we write our equation, that's going to be our initial thickness, 6.21 times 10 to the -9. And whenever you fold paper, we double the thickness, and we want to find out how many folds in order to get 0.25 miles tall. Now, I'm anticipating when we graph this that our number of folds is going to be on the x-axis, and we're going to start with 0, and we're going to go up. I would think that we don't need to consider any more than 50. So this is going to be our x min and our x max. And then we want to find out when it reaches 0.25 miles tall. So this is really our thickness or our height. And so if we set 0 for our y minimum and 0.25, let's just go up to 0.5 for our y max. Well, what's going to happen then? This growth is going to look like something like that, and we want to find out when the growth reaches the number of folds. So we want to find out that x value. So this is how we're going to put it in our calculator. If you go to y equals button, we're going to put y1 equals this equation, which is parentheses 6.21. Now we can write it times 10 to the -9th power, or there's a shortcut, and it goes like this. Instead of writing times 10 to the -9, you use this double E right above the comma. So that means times 10 to the -9th power, and then we're going to go growth factor of 2 to the x power, which is the number of folds. And then we want to find out when it reaches 0.25. Now, if we graph this, we're really not going to see anything, because what we want to do is go to our window, and we know we want to see only the first quadrant and the x minimum from 0 and maybe up to 50 folds. And then our y, we really only need to go from 0 to 0.5. Now we should see a picture that looks something like this. Let's take a look. There it is, there it is. And so this is the intersection that we want to find. So we can go second trace to get to the calculate menu. We want to go down to number 5, press enter. The first curve we press enter, the second curve we press enter, and we guess by pressing enter. And we find that the intersection is at 25.2. Now if we chose 25 folds, we're not quite going to reach a quarter mile because we need 25.2, which you really can't get a 0.2 fold, so it's going to have to round up to 26 folds. We can write the answer. It takes 26 folds to reach a quarter mile